All right, we're back. Number 14. So find the interval on which it's decreasing. So you're given the derivative, great, and ask where is it decreasing. So that is the derivative, so you don't take the derivative, it is it. So make it equal to 0. We need to find the critical values. There's nothing that makes it undefined. So we make it equal to 0 and solve it. So first of all, we're going to factor it. They all have an x, so take out an x. And then what's left over, you can use a diamond, but I know you can do this in your head. Two numbers that multiply to -5 and add to -4. That's -5 and +1. That means the answer. X gives you the answer 0. X minus 5 gives you the answer +5. And x plus 1 gives you the answer -1. Do a number line using those numbers. So in order, -1, 0, and 5. Plug in numbers. So plug in a huge negative number and see what the answer is. So if you plug in -1 billion, the answer is negative, because you get a negative times a negative times a negative. Between -1 and 0, like -1/2, you actually end up with a negative, negative, and positive, which is positive. Plug in a number, any number between 0 and 1, like 1, between 0 and 5, like 1, which ends up being a positive, a negative, and positive, which is negative, and then plug in a huge positive number, and the answer is positive. Now, I know in the question it's not plural, but it should be. So in what intervals is it decreasing? So we know it's decreasing from -infinity to -1 and from 0 to 5 right here. So where is the function decreasing? From -infinity to -1 and from 0 to 5. All right, number 15. Find the limit as x approaches infinity. What they're actually asking for is power over power. What's the n behavior? So what's the power on top? -5x to the fourth. What's the power on the bottom? Be careful because of the exponents. We have x squared, but we also have 2x squared. Well, 2 squared is 4x squared. See how you have to be careful? So on top is -5x to the fourth. On the bottom is 4x to the fourth. So what is the n behavior? What value does it become as it gets closer and closer to infinity? And the answer, when you cross it out, -5 over 4. So remember, this means n behavior, power over power. And don't make sure you're aware of the exponents. And if there's a constant that needs to be squared, so like the 4, 2 squared to get the answer. All right, number 16. Number 16, find the absolute minimum and maximum of this. Y equals -x cubed plus 4x from 0 to 2. So to do that, I'm going to take the derivative. That's -3x squared plus 4. We're going to make it equal to 0, and we're going to solve it. If this goes too fast, you press pause. So I'm just going to leave it that way. Square root of 4 over 3. It's plus or minus, but the negative we don't need because it's not in the interval. So in our interval from 0 to 2, I'm going to do table of values. So we have 0, we have the square root of 4 over 3, and 2. So I know 4 divided by 3 is a little bit bigger than 1, and that square root of a little bit bigger than 1 is in between 0 and 2. So a little number sense, I know that's in the middle. The y value, if you plug in 0, the answer is 0. If you plug in 2, you get -2 cubed plus 4 times 2, so that is -8 plus 8, right? Make sure that I'm not making a silly mistake. 2 and 2, that's 0. And then plug in root 4 over 3. So 4 over 3 4 times 4 times 4, there's that. This is 16 over 3, but I'm going to, instead of 16 over 3, I'm just going to change it to 48 over 9. Just top and bottom times 3, because I want common denominators, and then subtract the 2. So it's not, what is that? 16. So it's -16 over 9. So where is the absolute minimum? So the absolute minimum is -16 over 9. The absolute max in that interval is 0. All right, number 17. A projectile, press pause, and you can do it when you're ready. Press play. A projectile is launched from Hilltop, and it's given by this equation. And it says, and t is in seconds, s of t is in feet. How many seconds till the projectile reaches its max height? So max height in this case means the vertex. So using calculus to find the vertex, that's a maximum or a minimum. In this case, it's going to be a maximum. But anyways, you can take the derivative, make it equal to 0, and solve it. So take the derivative. What does t equal? Subtract 32, divide by negative 32. You can see what solves the equations. 1, what did you just find? So at 1 second, or after 1 second, I should say. So after 1 second, right, it reaches its maximum height. And then it says, what is that height? Well, then you take that 1 and go back. So go back to the equation, and where there's a t, plug in 1, and then solve it. This is negative 16 plus 32 plus 200. So that's 16 plus 200, which is 216 feet. So using some calculus to find the vertex. Algebra would use negative b over 2a, which would take longer and wouldn't be as simple. So there you go. Last one, number 18. I need a separate piece of paper for this one. 18. Here we go. So this is a great question. So this one kind of ties it all together. You're given y equals 2 over x squared plus 4. The first derivative is negative 4x over x squared plus 4 squared. And then the second derivative is 12x squared minus 16 over x squared plus 4 cubed. All right, so let's just start at the beginning. So domain. What would the domain be here? So look at the denominator. Is anything that would make it undefined? X squared plus 4 means it's all real numbers. There's no value to put in to give you the answer 0 on the bottom. Look at the next one. What's the next thing? X-intercept. So when I look at the x-intercept, look at the top. There's no variable on top. There's nothing to plug in that will give you the answer 0. That means there is no x-intercept. Y-intercept. You plug in 0 for x. So when you plug in 0, you get 2 over 4 or 1/2. Vertical asymptote. None, because there's nothing there's no domain restriction. Whole. None. There's no domain restriction. It's continuous. What's the next thing that says? Horizontal asymptote. We got something there. So that's power over power. So the power on top and on bottom, notice the bottom is more powerful. That means the end behavior goes to 0 when the bottom is more powerful. So that means the horizontal asymptote is y equals 0. That's the next one. Symmetry, we'll talk about later. Draw first and second derivative number line. So you have a first derivative number line. So what makes it 0, or what makes the top 0 is actually 0. Nothing makes the bottom 0. And then plug in number. If I plug in a negative number, a negative times a negative is positive. If you plug in a positive number, a positive times a negative is negative. What did we just find? At 0, there's a relative max. And when x is 0, y is 1/2. That's actually the y-intercept. So we have 0 and 1/2 as a maximum and a y-intercept. There is no minimum. Second derivative number line. So notice the top here. It's a little more complicated, so I'm going to write it down. 12x squared subtract 16 equal to 0. Notice the bottom can't be 0, so it's just the top. Get x squared by itself. So add 16, divide by 12. That's 4 over 3. So it's positive and negative square root of 4/3, which is a little bit bigger than 1. Three over 3 would be 1. The square root of 4 over 3 is a little bit bigger than 1. So I need negative root 4/3 and positive root 4/3. There it is, sloppy as it is. All right, plug in any number smaller, like negative 1 billion into here, and the answer is positive. Plug in 0, and you can see the answer is negative, and plug in 1 billion, and you can see the answer is positive. So you can see where it's concave up, then down, and then up again. All right, we have enough now to graph this. So now let's put this all together into a graph. So the numbers I care about, 0 and 1/2. Let me just... Notice that there's point of inflections here. I need to actually find them. So if I find a point of inflection, I need to plug in, and it'll give me the same answer, positive or negative when you square it. So I'm just going to go the square root of 4 over 3 squared plus 4. So I went way back to the beginning. If you square a square root, you're left with just 4/3. If you add 4 to it, I'm going to make that 12 over 3. So we have common denominators. So that's 2 over 16 over 3. I know, I'm sorry about the fraction. The reciprocal, reduce it down, you get 3 over 8. 2 goes into 16 8 times. So both positive and negative will give you the same answer. So I said it's a little bit bigger than 1. So a little bit bigger than 1, we have 3/8. But let's get to that in a second. So we know we have 0 and 1/2. That's a maximum. We also know this one, which is a little bit bigger than 1 and 3/8. So not quite 1/2, a little bit smaller than negative 1 and 3/8, a little bit lower than the 1/2. We also know that there's an asymptote over 0. And now we're just going to complete it. So we know the end behavior is 0. We know first it smiles. So it smiles, and then it frowns, and then it smiles again at the end. So it smiles, then frowns, and smiles, and we have a maximum at 0 and 1/2. So smile, frown, smile, and the ends are going to 0. All right, there's your test prep. Make sure that you go over the unit packet. I guarantee you that every question I went over with you, 1 through 18, will be on the test in some form or another for you to think about and study over. So it's a good thing to study and get those. And I tried to pick the more tougher questions out to make sure that we went through some of them ahead of time to give you a chance. So study, and I wish you the best on the test.